Why scanner prefers offsets? Instead of storing line or column for every token, many compilers store start offset, comma length because they already know those numbers while scanning. It's cheaper. Line or column is only needed for errors since the scanner only return this when they encounter an error and they already know the line and the column using the location of the token type. Therefore, it prefers the offset or the start of it in the file and its length. It's not because there is some theory or some mysterious reason why, but it's because they already know the start offset of that UTF-8 bytes and the length. It's more of a computer science theory whereby you know the start of the bytes and then the last bytes in the file. So most tokens never appear in error message. So a file may contain 100,000 tokens. Maybe only one token causes an error. Computing line or column for all 100,000 tokens would waste work. How does connects to React? So React does a similar representation pipeline. Notice the pattern: source to intermediate structures to execution. React does a similar representation pipeline. Notice the pattern: source to intermediate structures to execution, exactly like a compiler. The deepest connection, the profound insight. Computer science is largely the art of transforming one representation into another. Example: UTF-8 bytes to tokens, tokens to AST. So again, computer science is largely the art, so it's an art of transforming one representation into another. It's like transforming what is the business goal into what computer can actually automate. Tokens to AST, AST to bytecode to machine instructions, React elements to fiber nodes to DOM mutations, objects to JSON to UTF-8 to network packets. What you're missing, the main omission, the missing mental model, compiler structures, tokens, AST, grammar, and runtime structures, stock heap objects are different layers. That distinction is what will unlock advanced topics like V8 internals, JIT compilation, React Fiber database, query planners, operating systems compilers. For your level, this is the 80-20 truth. Source code is text. Compilers transform that text into structured representations. Runtime systems execute those structures using stock and heap memory. React, TypeScript, databases, and operating systems are all different versions of the same fundamental idea, transforming representations to produce behavior. That's the loop you've been trying to close. So, we're trying to connect compiler theory, operating systems, memory, data, structures, JavaScript, React, TypeScript, and CPU execution into one mental model. That's exactly the right goal. What's happening is that you're trying to hold too many layers of abstraction at once. So your brain keeps mixing them together. The single most important correction: the breakfast grammar is not a runtime object. It is only a mathematical description of valid token sequences. So again, it's related to the token which were passed from the UTF-8 bytes. The layers you're mixing together: compiler pipeline, first source file UTF-8 bytes, bytes on disk 76, 65, 74, 20, 60, 61, 6E, 67, 75, 61, 67, 75, 23D, 20, 20, 60, 6F, 78, 22, 3V. So these bytes mean var language equal quote lock semicolon. Now transfer to scanner or lecture. As you can see, it has a search symbol or magnifying glass. So it group bytes into tokens like var to code var identifier to language code language equal to code equals string to code lock semicolon to code semicolon. Then parser uses the grammar to build an AST. Variable declaration name equal code language value equal literal code locks. For runtime or VM, execute the AST or bytecode, create variable code language and store value code locks. CPU executes machine instructions, load memory, compare values, store bytes, jump, call function. Now let's fix your biggest confusion. Breakfast produces fried eggs with toast. In the grammar chapter, breakfast to protein with breakfast on the side. Breakfast is a non-terminal symbol, not food. It means expand according to this rule. The parser is not cooking breakfast, it is checking whether a sequence of tokens matches the grammar. So it is checking whether the sequence of those tokens we parse matches the grammar. So now this is where the structure or the coding skill of programmer enters, because you need to put that in the right sequence in order to avoid this parser error. So example in programming grammar, expression to expression plus expression, the next line expression to number. This can generate token sequences like number plus number, then number plus number plus number. Those are valid strings in the grammar. So how grammar becomes AST classes? This is the key compiler insight. Grammar rule, expression to number becomes AST node. So grammar rule, expression to number becomes AST node. Grammar rule, expression to expression plus expression becomes AST node. So the parser transforms tokens to a tree of objects. So where stack and heap enter? Heap versus stack. AST nodes live on the heap. Example, binary node, in left we have literal 1, in right we have literal 2. So function calls live on the stack. So for example, parse expression function, first it calls parse term and then calls parse factor. So these are the function inside it. So each call pushes a stack frame. When the function returns, that frame is popped. The parser stack versus runtime stack. Parser stack, so while compiling, parse expression, then next line parse term, then parse factor. While a runtime stack, while executing, you have main method, and inside is greet method, and then next inside is greet pops, and then main continues. So your I value or R value confusion. This is the closest to correct mental model. Concept, identifier, meaning, name means source code. Concept, symbol table, meaning maps names to runtime slots. Concept, variable storage, meaning actual memory allocation. Concept, heap object, meaning runtime value. For the parser creates variable declaration. Name equal code language, next line initializer equal literal with a parameter code locks. So later at runtime, it creates a variable slot for language, allocate string object code locks on heap, store a reference or pointer to that object in the variable slot. So how React connects to all of this? React transformation pipeline. First JSX source. We have button, closing button. Second compiler. React that create element with a parameter button. Third, runtime object. We have type button and then comma props with the value empty object and then closing. Then fiber tree, link graph of UI nodes. Then reconciliation, diff all tree versus new tree. Then DOM mutations, browser update pixel. So why ID keys matter in React list? When rendering arrays, the keys let React match old fiber nodes to new nodes. Without keys, React may reuse the wrong UI node, causing stale UI state. So your strongest insight, this is the deepest thing you've said. There are a lot of data structures happening from source file up to CPU. Yes, that is exactly why what systems are. A modern program is a chain of representation transformation. UTF-8 bytes to tokens, to ASD to bytecoder IR to machine instructions to CPU state changes to pixel on screen. The three subtle misunderstanding to fix. This will matter later. First, grammar symbols are not runtime objects. Grammar exists only during parsing. Second, stack and heap are not data structures in source code. They are regions of virtual memory managed by the runtime and OS. So it's a region of virtual memory. The stack and the heap is actually the region of virtual memory that are managed by the OS. It's not the data structure you would see in a source code, or it's not a data structure in a parsing per se, while parsing in the UTF-8 bytes. Rather, it is provided by your OS. So it's a managed runtime memory. Third, tokens are not generated from a hash map. So the scanner reads bytes sequentially and creates tokens object directly. So again, tokens are not generated from a hash map. The scanner reads bytes sequentially and creates tokens objects directly. It isn't coming from a hash map, which is a later phase in the compiler step. So the mental model I keep, one sentence: programming languages, compilers, React, databases, and networks are all systems that repeatedly transform one structured representation of information into another. That's the love you've been trying to understand.